What's going on, everyone? Welcome. Today I'm going to teach you object-oriented programming in Java. As you know, Java is very popular programming language in testing and development. And today I'm going to teach you everything you need to know about object-oriented programming in Java. I'm going to start from class members. Also, I will talk about static concept and also inheritance, interfaces, abstract classes, polymorphism, and encapsulation. So basically, I'm gonna teach you everything you need to know about object-oriented programming. If you haven't done yet, please go ahead and watch the Java first video because I was covering up all the basic fundamentals of from the loops through to the different kind of arrays, array list I covered in the previous video. So if you haven't yet, please go ahead and start from that one. It is gonna be very useful. Also, if you haven't yet, please subscribe to my channel. It is very important for me, and hit the like button if you think it's really helpful. So let's get started. Guys, this is Ahmet Can Türk. In this tutorial we are going to learn member of the classes, and we are going to learn fields, objects, methods, and constructors. So let's get started. I created my class concept 1. I want to note that there can be only one public class in per source file, and a source file can have multiple non-public classes. In this source file we are going to create some other classes. I'm going to write down right now. So the first class is going to be named as class myClass. So I'm using my class keyword in order to create the class myClass. And in order to create the class, we need to have open and closing curly brackets. And now my class is ready. Well, all the classes have fields, methods, constructors, and some other components. Today we are going to go over the fields and constructors and methods. Fields are basically variables that we are going to create inside of our classes. So classes have fields, methods, and constructors as members. Well, fields have different names. Fields, global variables, and attributes. They are all names for my variables. I can declare some variables in my class like this: integer x and string y. These are my fields. So fields, they have another name, global variables, and another name is attributes. Well, since I created my variables inside of the class, that means all the object that I'm going to create out of this class is going to have these values, integer x and string y. And every object that I'm going to create is going to have different x value or different y value. Now I'm going to write down that the next thing is constructors. I can create constructor, basically right click source and generate constructor. So let me do that again. There you go. Now this super keyword is useless. I'm going to erase it. And now this is my constructor. Constructor are special blocks that are being used when I am creating object from this class. We are using constructors in order to initialize the object, and if we don't declare the constructor, Java is going to create us a default constructor, and this default constructor is not going to have parameter. So let's say if I erase this constructor right here, in the backside of the Java I have one non-parameter constructor. But right now, since I created my constructor, I will use my two-parameter constructor in order to produce an object from this class. Now I'm creating another constructor. If you write down the class's name, Eclipse is going to create constructor for us. Now this is non-parameter constructor, which has no parameter. Now I'm going to write down inside of my two-parameter constructor, I'm going to write down that two-parameter constructor has been used. And in my non-parameter constructor, I'm going to write down this similar thing. I'm going to write down no parameter constructor has been used. So while I'm creating object, I will use different constructors, and with these messages I will be able to see which constructor that I used while I'm creating my objects. Now let's get to action. I'm going to go to my class concept class, and we will start to create some objects for this class. I'm writing down my class name and I'm creating my object. This is how we are creating object. We are writing down the class name, object name, and in the other side of the equation, new keywords and class name again. Now my object is ready, and in the right side of the equation I have constructor. So inside, right next to my new keyword, I have my constructor, and if I put two parameter inside of my constructor, that means I am using two parameter constructor. So we created two parameter constructor in the class above. Right now I am using this two parameter constructor. We are basically overloaded constructor. So right now, while I am creating my object, I am using my two parameter constructor. I'm writing up system.out.println these data has been initialized by constructor, and I will reach out these fields with using my object reference, my object.x. So now I am reaching out this x field inside of my class above with using my object, my object.y. When I hit the run button right now, it will say two parameter constructor has been used, and these data has been initialized by constructor. Now I'm going to change my system.err into system.out. Let me change it. So system out. Now I'm going to call it again. And first of all, two parameter constructor has been used message. This message is coming from the constructor, and these data has been initialized by constructor 10 and Java. Well, we initialize our object in the line 32, and we basically put our data with using this constructor. Now my object right now has fields x and y, and these fields have different values. I'm going to create another object, and this object name is going to be my object2. My class, my object2 equals new my class. Now I'm gonna leave my constructor like this without using parameter. Now I'm gonna write down we are using no parameter constructor here, and I will use my object reference in order to put the values to fields. My object.x equals 12, and my object.y equals some string. Now I will print out again some message. I'll copy from this message in the top, and I will say that, so instead of constructor, right now I initialize my object with reference. So I will say that these data has been initialized by reference, and I will change the object name. So in the first one we use our constructor to initialize the object. In the second one we use our reference to initialize the object, and when we run the program we will see these messages. Now it was the first example for creating class and initializing the fields and constructor. So we will make another example, and in that example we are going to explore more these classes and fields. Now if I comment one of these constructor with non-parameter constructor, my non-parameter constructor in the bottom is going to give me error. If I uncomment it, error is going to be gone. So if I erase any of these constructors in the main method, my constructor callings are going to give me error. So let's get back to another example. In this example we are going to learn some real life examples. Now let's say we have a cell phone class. We need to choose our fields for what can a cell phone class have like can have. Well, let me write down that class consists of fields, methods, and constructors. If we have a cell phone class, that means our fields and methods need to resemble to our class name. Basically, I need to create fields that are fields and variables that are defining the class, and methods are also needs to define the class in a function way. So it needs to define its actions. I am writing down string manufacturer. This manufacturer is my field, and one cell phone can have a field which is named as manufacturer, and cell phone can have model, and cell phone can have retail price. So these fields, or in other words I can call them attributes, they are defining the class. Next thing is I'm going to create some methods. Methods are special functions which describes actions that class can have. I'm going to create one method which is void call. Well, every phone can call, right? That's why we are creating a call method. And inside I will print out system.println cell phone is ringing. Now the next step, I'm going to create some other methods, which is like void show model, and this method is going to print out model for me. As you can see, I can directly reach out the fields and use them inside of my methods. I'm going to create another method, and this method is going to show me the price. Now I created in double way, so I need to say return the retail price. Now whenever I call this method, this method is going to return me the retail price of the cell phone. Now the next thing is we are going to create constructors. Constructors are being used in order to initialize the objects. If I write down the class name as cell phone, the constructor is going to be created automatically if I hit enter. Now I will say, like, every time we create an object for the class, one of the constructors will be invoked. Next thing is I'm going to create another class, and this another class is going to have main method, and I will operate my program from this another class's main method. Now I create it. I'm going to put it inside. I will drag it. Alright, so now in the left side we have cell phone class, and in the right side we have cell phone test class. I'm going to create my objects, and I will going to call the fields and the method from this cell phone test class. In order to create the object, of course, I'm going to use my cell phone name. So I'm going to write down cell phone. Let me write down that this class will hold the object of cell phone class. In my main method, I will start to write down these things. So right now the manufacturer name and the model and price is going to come from user. So I will ask these fields from the user actually. So I'm creating variables for each of these value that I'm gonna get from the user. So string test mode and double test price. So these are gonna hold my values that I get from the user. I will use my scanner object for this example. So create a scanner object for keyboard input. I am creating my scanner object. It's going to be named as keyboard equals new scanner system in, and I will ask my question, and I will assign the variable into keyboard.nextLine and keyboard.nextDouble. Now my main method is ready almost. So I will ask the user for some values. Manufacturer and model and price name is going to come from user. Now I can create my instance, my object for cell phone class. I will pass the data that was entered by the user as an argument, and I'll pass them I will assign them to my reference.manufacturer, reference.model, and reference.retail price. So let's create the object. Object name is going to be phone. Now I use my reference to assign the fields. Now I am creating an info method in the left side, and this info method is going to print out all the fields whenever I call this method. So manufacturer is the manufacturer, plus model is model, and retail price is retail price. Now my info method is also ready. Price, okay, now it's ready. So I'm going to hit the run button, but I need to click on this file before, and I need to write down that phone.info. And when I hit the run button right now, this method is going to print out all the fields. So run. The program asks for manufacturer. I will write down Apple. Model is going to be iPhone. So price is going to be $1,000, and it's printing out manufacturer, model, and iPhone model and price. So this is how my program is working. Thank you so much, guys, and see you at another tutorial. Hi guys, this is Ahmet Çantürk. In this tutorial we are going to learn how to create objects in Java. So let's get started. I created a class which is creating object class, and I will have my main method inside of my class. From this main method we are going to declare different objects for the class. I'm creating another class in the top which is going to be named as declare. After creating class, I am going to show you guys how to create different kind of objects. There are three ways. The first one is creating object reference, and after creating the object reference I am going to assign an object to this reference. First I am writing down declare object1 equals new declare. In this statement object1 represents the reference, and in the right side of the equation we have new declare and parentheses. This is actual object creation, and now my object1 reference is assigned to this object, and I can use my reference and I can do some calculation. I can reach out the fields and methods that this object has, and in order to do that I will use my object1 reference. Another way to declare object is creating anonymous objects. Anonymous objects are a good approach to if we want to use our object only one time. I am using new keyword and class constructor which is declare and parentheses. This is my object right now. The reason that it's anonymous is because it's not assigned to any other reference. Now I'm going to create one method in my declare class, and with using this method I'm going to put one statement, system out println and method in declare class. Now the reason I'm creating is because I will use my anonymous objects to call this method. Now I'm creating another anonymous object, new declare, and we can use this anonymous object to reach out this method, and if you run this program we will see this message. Now another thing is creating multiple objects in one statement. We can create multiple objects in one statement. I'm going to write down declare object2 equals new declare, and comma, instead of semicolon I'm going to put comma, and I will write down object3 is equals to new declare, and again comma, I will write down object4 equals new declare. So this is how we are creating the objects, guys. First we are using just one reference and one object. The second one is anonymous object, and the third one is creating multiple object in one statement. So thank you so much and see you at another tutorial. Hi guys, this is Ahmet Çantürk. In this tutorial we are going to learn Why do we need constructors? And 3 ways to initialize the objects in Java. So let's get started. In my initializing class, I am going to create some fields and methods. And in this example, we are going to see why we need constructors. Let me explain it a little bit. We are using constructors to initialize the objects. Initializing means giving value to the object fields, and our constructors is going to help us to give value to our fields. Well, even though we don't create any constructor, Java has non-parameter constructor by default. Now we are creating our fields, private string name and private integer ID. These are going to be 2 fields. As we know, every object that we create for initializing class is going to have name and ID variables, and we have different ways to initialize these fields. One of the ways is creating constructor. The other way is creating getters and setters. The third way is directly reaching out the fields. I'm writing down this class has getters and setters and constructors. As you guys know, getters and setters are special methods to set my values, set my fields, and get my fields from another classes. Now I am creating constructor with using source, and I have constructor right here, which is 2 parameter constructor. This is 2 parameter constructor, and these are getters and setters. I am going to use setters in order to initialize my fields for the objects. I copy and paste them to the bottom of the main method. I'm writing down different ways to initialize objects. First way is initializing the fields through direct access to with the reference. So we will use our reference to direct the access to the fields. Even if my fields are private, now I am inside of this class, so I will be able to have access to these private fields. So I can use my direct reference. But if this main method would be in another class, I wouldn't be able to reach out these private fields directly. So I created my references, and as you can see, I have 2 parameters right here. I need to write down 2 arguments inside. Right now I cannot create object. I cannot create the object with using non-parameter constructor. In order to do that, I need to create non-parameter constructor. And if we erase this, now I can just directly create my reference, no problem. But if I erase this non-parameter constructor, I cannot initialize my reference without arguments. So I'm using my reference dot name and reference dot ID, and I will assign values to it. First, reference dot name is going to be Ahmed, and reference ID is going to be 4298. This is how we are initializing the object fields through the reference access. Second way is I am going to initialize the object through methods, and this method is going to be setters. I will use the setters in order to reach out the values, and in order to set the value for the fields. Now I'm using my reference to dot setter, and this setter is going to set name. I will choose the set name and I will put the name. It's going to be Mike, and reference to that set ID 4299. Third way to initialize the object is I am going to use 2 parameter constructor, and this 2 parameter constructor is going to initialize my object. So this is reference 3 equals new initializing. Instead of non-parameter constructor, in line 27 I use non-parameter constructor, but here I will use two parameter constructor, and I assign the names and ID. Now I initialize my object using the constructor. This is the third way to initialize the object. I'm going to write down that we use constructor while creating the reference 2 and reference 3. In order to create reference, I used non-parameter constructor, and in order to create reference 2, I also used non-parameter constructor, but in order to create reference 3, I use two parameter constructor. And even if we don't create a constructor in class, Java provides a default constructor. Default constructor is non-parameter constructor. But right now, in this case, if I erase this non-parameter constructor, Java is not going to provide one. Java is only providing non-parameter constructor when we don't have any other constructor. If we don't have any other constructor, that means we have default non-parameter constructor. But if we are creating another constructor in my class, such as one parameter or two parameter constructor, that means I no longer have a default non-parameter constructor. And in order to create an object with using non-parameter constructor, I need to create non-parameter constructor in my class. Now I'm creating an info method, and this info method is going to print out all the fields of my class. And of course, if I call this info method with different references, I will see different outputs. The name and ID belongs to different objects. Now I am calling the reference.info, but before I need to set some like stars to differentiate the names and IDs. Reference.info, reference2.info, and reference3.info. These statements are going to call the object's name and IDs, and of course every object has their own name and IDs. Let me call it. In the console you will see name and then ID of the different persons. Alright, thank you so much guys. This is all today. We learned 3 ways to initialize the objects. See you at another tutorial. Hi guys, this is Ahmet Can Türk. In this tutorial we are going to learn static members of the classes. Static members of the classes have always one memory, and we are going to learn how they are different from non-static fields of the classes. So let's get started. Again, static fields has only one memory. All the objects will share the same value, but non-static fields can have as memory as the number of the object. So objects don't have to share the same value. We will see in example like how they are different from each other. For the example, I'm going to create two fields. One is going to be static integer and other is going to be non-static integer, and I will assign both integers into 0. Next thing is I'm going to create one method, and it is going to change our fields, and it will add 5 to each fields every time I call this method. So every time I call this method, my I and count is going to be increased by 5. Now my method is ready. So now every time I call this method again, this I and count is going to increase by 5. But as I said, I is going to have more than one memory place, but count is going to have only one memory place. So we will see how they are different right now. I am creating an object for my class, and I will create another object. I will create two objects. I am going to use these objects, and I will call my method of change count with these objects, and every time I call this methods, again my I is going to increase by 5, my count is going to be increased by 5. But the point here is check1 has different I value and check2 has different I value, but both of them has the same count value because count has only one memory. So it can only hold one value, but I can change depending on the different object. Well, since I can be 10 for one object, it can be 20 for another object. But count is not like that. Count is going to be always same for all of the objects because it is static member of the class. Now I'm going to create print method for each field and each object. I'm going to document like what is I and count for in each statement. There's going to be a couple of questions in Java certification exam about these static fields, so better learn it very well. Again, count will be same for all the objects. And in the first line, count is 5 because I increased the count by 5 and I use the object check1. And in the second statement, check2 that change count, my I is going to start again from 0. It will go to 5, but my count is going to start from 5 and it will increase into 10. So this is an important point. I am creating my printer methods right now and we will see how these objects and fields are, like what is their values are. If I hit the run button, I will see the values. Check 1 I equals 5, check 1 count equals 10, and check 2 count equals also 10. Well, as you can see, count is same for all the values, but check can be different. Check can be different for all the objects. I can be different for all the objects. Now the next thing is I'm going to create static method. Static methods have one thing. Well, in order to use fields in my static methods, these fields need to be static fields. I cannot use non-static fields in my static method. So if I create an increase method like this, I can only increase my count. If I try to increase I, it will give me compiler error, so I need to comment it, and I need to write down here that in my static methods, non-static fields cannot be used. Well, this is one example, and I'm going to create another example to make things more clear. In this second example, I am going to use my previous class. In the previous example, in the previous tutorials, we created declare class. If you can't find it, you can find in below. I will leave it in the below, so you can copy and paste it, paste the code. I will use the pre-written code in order to show the static example. What I'm going to do is, in this example, I am creating bunch of objects. First of all, let me copy this code. I'll copy that, and I will paste the same code in my class, but make sure that these packages should be different, because in the same package I cannot have the same class's name. Alright, I will modify the class names and make it suitable for my class. Make sure that all the public class has their own Java file, so the file name needs to match with public class name. Now I'm changing it into static concept 2. My public class has been named as static concept 2 right now. So I am creating a bunch of objects in this example, and what I'm going to do is I will count how many object has been created in this class. In order to do that, I need to know like what's going on when I am creating an object. Let me clean this class a little bit. Just keep in mind that every time we are creating an object, our constructor is being triggered, and if I put something in my constructor, then I can if I put like counter in my constructor, then I can count how many object has been created. If we put static integer to the constructors, we can count the number of objects. Now let's create the constructor. My declare class, as you can see, doesn't have any constructor, but right now it has default one. Default is non-parameter constructor. Now I can create one constructor. Still, it doesn't have any parameter, but right now, every time I create an object, this constructor is going to be triggered. So now if I can put some counter inside of this declare constructor, now then that means I can count how many object has been created. I am going to declare this outside of this constructor, static integer count equals 0, and count plus plus is going to be inside of my constructor. Again, I will count like how many objects there are and how many times I'm using my constructor. Well, in the old new keywords, as you can see here, I am using my constructor. So new declare parenthesis means a constructor. And now if I run this program, I will see that 6, which means 6 object has been created. Let's count. Is there that much object? Just count the new keywords. 1, 2, 3, 4, 5, 6. So there are 6 object has been created, and my program right now shows me how many object that has been created from this declare class. Let's check if this count object wouldn't be, count variable wouldn't be static. What was gonna happen? If I run this program, first of all I will see an exception. Let's try to find out what's this exception. Alright, we need to call this count with using an object. Now I will use any of these object, doesn't matter. I'll use the object 2, and when we do the object 2 we will see 1. Well, it's not giving me the right answer. When we do it for object 3 and object 4, all of them is going to be 1. Well, because my count right now it's non-static, and it means it has one value for each of the objects, and since every object is using the constructor only one time, that's why I'm seeing 1. But if I change it into static, every time any object use this constructor, it will keep increasing and increasing. So I will see 6. So this is how static and non-static fields are working. Thank you so much guys, and see you at another tutorial. Hi guys, this is Ahmet Can-Türk. In this tutorial, we are going to learn inheritance in Java. So let's get started. In inheritance, we will have subclasses and superclasses. And subclass will inherit all the properties from the superclass in inheritance, except private properties. Inheritance only work in one way, and properties will be inherited from superclass to subclass, but properties won't be inherited from subclass to superclass. Let's create our superclass and subclass. I'm going to write down class, superclass. So superclass is an identifier name, it can be anything. And now I'm going to create my another class, subclass. Also subclass is an identifier name, so it can be named as anything you want. In order to connect these two classes, I'm going to use extend keyword and extends to superclass. Now these two classes are connected. If these two classes are connected, we will know that superclass and superclass properties will be inherited to my subclass. If you remember, in order to reach out the fields and properties of any class, we need to create an object for this specific class, right? So what I'm going to do is I'll create one properties here, integer x. So this is the property of superclass. And in order to reach out these properties, I need to create an object for superclass, right? So superclass object right here. And I can use this superclass in order to reach out these properties. And now I can assign this value to x. Now I can connect to my integer x with superclass object. Well, the different thing here is if we are using these two classes in inheritance relationship, if we are creating subclass object, well, subclass object also object will also have access to my integer x right here, because we connected them with extends keyword. So I will do that. Subclass equal new subclass. So this is the subclass object. So subclass x equals 10, or it can be any number, doesn't matter. So now I have access to this integer x also. Well, in order to have the access, I need to have inheritance relationship. Inheritance means connecting these two classes to each other. But my superclass is the superclass, which means the properties, well, properties can be method or fields. So methods or fields will be inherited from superclass to the subclass, but not the other way. So now I can use my subclass object in order to reach out the superclass properties. Now let's check what's going to happen if I erase this extend superclass keyword. If I erase this, as you can see, I have compiler error, because if I don't have any connection between these classes, then it means that in my subclass, I don't have integer x field. So if I lose the connection, that means I will not be able to reach out this integer x anymore. So I need to put this back again. Now I will create some other fields like string y, and I can create one method. So I created my method, and I will say this is method 1. Now I can reach out this method with using the subclass object and superclass object, because this method has been inherited to my subclass also. Even though I cannot see it in here, this method has been inherited, so I can reach out this method in the subclass object. Well, if I can connect these methods and fields, that means my class right now have these fields and methods. I cannot see them in my class, but with the extend keywords, I can know that I can reach out these public fields and methods. Now I will use my subclass object and superclass object in order to reach out this method, because both of them can reach. Now both of them can reach out this method. And when I hit the run button, I will see these messages from these method callings. Now I will create some other fields for my subclass. So these fields, A and B, can be accessible only by subclass objects, because inheritance is working one way. Inheritance only work in one way. Properties will inherited from superclass to subclass, but properties will not be inherited from subclass to superclass. All right. So my superclass will not be able to have these A and B objects, A and B fields. Now I will use my superclass object in order to reach out A and B, but we will see that it's not going to work, because superclass doesn't have access to subclass properties. Let me write down here. Now this is going to be compiler error. Next thing is I'm going to create one private method for superclass, and I will check if my private method or private field is going to be inherited to my subclass. So what I'm going to do is I will change one of these fields into the private. So for example, let's take the superclass X. Well, right now superclass this integer X has been inherited to my subclass, even though I don't see it here. I can use my superclass object in order to reach out this X. Actually, this is not a good example. I'm going to use my subclass. So subclass object has the access to X, right? Let's see what's going to happen if I make it private. If I make it private, my superclass X and subclass X, both of them is going to lose the access, because right now I'm in the different class. So I'm going to put it back again. In order to see if private methods are accessible from a subclass or not, I am going to create one method here. So this method 1 is going to use integer x. So I'm going to say that system out println print x, and now it is working, right? So I can access to this x from the superclass, but if I make it private, I will no longer have the access, okay? Because private fields are only accessible from the same class, and my superclass is different class than subclass, so I will not have the access to private fields or private properties. Now I will erase it, and I will say that, or let me put it back, and I can note here that compiler error, or I can note that private properties are not accessible from subclasses, right? So I need to comment these also. Now is okay. So this example demonstrates how my superclass properties inherited to my subclass, and how my private properties are not being inherited to my subclass. So I'll make another example. I'll open my inheritance concept 2 class. Okay, another reason to use inheritance is we are using inheritance concept to categorize our classes. So how are we going to categorize our classes? I'm going to make real life example. I will create employee class, and this employee class is going to have some fields like string name, integer salary, and I will have another class, and this another class is going to be named as teacher, and this teacher class is going to extend to my employee class. So now, as we know that this teacher class is going to have access to name and salary, we can say that teacher is an employee, so that teacher is going to have name and salary at the same time. We are always writing down the common properties to the superclass and more specific properties to the subclasses. Now we know that every employee is going to have name and every employee is going to have salary. And we are going to create different employee classes such as teacher, and I'll create another one is going to be named as data scientist. It will also extend to employee. And the other thing is I will have housewife. So housewife also an employee, and it will have name and salary. Now, since all of them has name and salary, if I create object for each employees, then I will have name and salary properties. The next thing I'm going to do is I will define more specific properties for these classes, such as every teacher has like student numbers. So data scientist has another thing like integer number of projects. And like housewife has another thing like string number of children. Now, if we check our classes, my teacher object is going to have name, salary, and integer student number. If I create data scientist object, it will have name, salary, and number of project. If we create housewife object, it will have name and salary and integer number of children. But if we are creating employee object, my employee object is going to have only name and salary. It's not going to have any of these subclasses properties because inheritance is only working one way. Now I'm going to create another example. I created another class, and we will demonstrate another example in this class. We will demonstrate a multi-level inheritance in this example. So let's start. I'm going to create one class. One class is going to be named as A, and another class is going to be B, and B is going to extend to A. And another class is going to be C, and C is going to extend to B. So C extending to B, B extending to A, and A is the superclass of all of them. Now I will create some properties. like integer a, and I'll create one method like method a, and I will do the same thing for all the classes, and I will change the names. So method b, and I'll do the same thing for class c, and I will change the name of the method and fields also. So every class has its own fields and method, field and method, and field and method. So these are representing properties. Now I will use my another class which has a main method. Now from this class, I'm going to create some object. So I'll create basically object for class C. After creating this object, now I will check out like what this object have access to. Of course, since I have inheritance relationship, my class A properties is going to be inherited to class B and also class C, because class C and A in somehow connected, because class C is connected with B and B is connected with A. So my C is connected with A, which means I will have properties of class A and properties of class B in my class C. So this object right here can reach out all these fields that you can see right now. If you click on C, you will be able to see like A, B, C, and method ABC. I can reach out all of these properties. So class C object have access to all properties of the super classes. And if we create an object for class B, the class B object is going to have access to integer B, void B, and also integer A and void A, which means it's going to have access to superclass properties. But if I create an object of class B, it will not have access of class C properties, because class C is the subclass of class B, but class B is the superclass of class C. So class B is going to have the access to A classes properties, but not C classes properties. So let's check them out. So let me write down here A, B, C. And if we create object of B, the class B object will have access to class B properties and class A properties. So if we create a class A object will have access to itself. So this is how multi-level inheritance is working. Now we will create another example. In this example, we will demonstrate how inherited superclass and subclass constructors are working. I will create two classes. One is superclass 1. I'm naming it as superclass 1 because we already have the superclass in another class. So I'm going to name it as differently. And another thing is subclass 1. And subclass extend to superclass. Of course, not superclass, superclass 1. Okay, this is ready now. I am going to create some fields for my superclass 1, integer x and string y. And I will create one constructor for this integer x and string y. I am generating constructor from source. Right click, source, and click on generate constructor using fields. Select all of them and click on superclass. Now, as you can see, right now, as soon as I create the constructor, my subclass start to give me error. Because if I have constructor in the superclass method, superclass class, and if this constructor have some parameters, then I need to create the same constructor in my subclass. Not the same, but I need to create a constructor and I need to call super, I need to use the super keyword. So this is giving me error. Let's see what's going to happen if I erase these parameters. It's not going to give me error anymore. Okay. So we need to, if we have parameter constructor in the superclass, which means we need to create another constructor in my subclass. So let's see what kind of constructor I need to create in my subclass. I will hover over to the problem and I will click on add constructors. It will create me constructor automatically. And now I am using my constructor, and this constructor is also 2 parameters, just like the superclass, and it's using super x and y. This is important because it is basically sending my x and y to the superclass while I'm creating an object. So as a short story, I need to create a constructor if I have parameterized constructor in my superclass. And if I erase one of these parameters, still it's not going to work. I need to have all of them. All right. So another way is actually if I have superclass constructor, and let's say I'm going to move this constructor also. Another way to handle this problem is I can create one non-parameter constructor here, and this is also gonna solve my problem. So if I use non-parameter constructor, this is also going to solve my problem in the subclass. Okay. So it doesn't matter, we can either use this constructor or not. It doesn't matter right now. And if I want to, I can use this constructor with my fields also. For example, I will create another properties here, string A and string B. And I can add these parameters inside of my subclass constructor. Let's do that. Integer A, string B. And after adding, I can assign them to parameters. Now there's one important point. This A represent the parameter, the field here, not parameter, and this A represent the parameter. Okay. Let's make it more clear. I'm going to make A1 and B1 as a parameter, and I will change them into A1 and B1. Now it is more clear. So this keyword is being used in order to specifically emphasize that I am using this A is the field A, and this A1 is the parameter A1. So whenever I use this keyword, that means I am pointing one of the member of the class. It can be either fields or it can be any method. So we cannot use this super keyword in the end of the statement. So if we do that, it's going to give me error because this super keyword needs to be always the first statement of the subclass. I'm sorry, the first statement of the constructor. All right, this is how inheritance constructors are working. Thank you so much, guys, and see you at another tutorial.
Hi everyone, this is Ahmetcan Türk. In this tutorial, we are going to learn overloading in polymorphism. As you know, polymorphism consisting of 2 concepts. One is overloading and one is overriding. In this tutorial, we are going to learn overloading. Let's get started. I created my class overloading concept, and we will create multiple methods in this class. Overloading is basically writing down the methods with the same name but with the different parameters. And overloading enables our method to be used in more flexible way. Instead of creating a method with different way, we are going to overload the method. In overloading, access modifiers can be different, but method names should be same. Also, parameters need to be different. I'll make the example with the different methods. I will create two methods. This method is going to be array printer, and as a parameter I will put some array. First array printer is going to print out integer arrays. I will use my for loop, and this for loop is automatically being created, and I will say system.println array.I. Now I will create one array, integer array, and integer array is going to have its values 1, 2, 3, 4, 5. Of course, right now this array printer is not going to print out my array elements. It's going to print out only 1, 2, 3, 4. Why? Because I just write down system.println I instead of array square bracket I. This is important. Now I am creating one anonymous object, and I am calling my method, and I am putting array inside. Instead of array elements, right now it's printing out 0, 1, 2, 3, 4. As you realize, my array elements are 1, 2, 3, 4, 5, but in the console I am saying 0, 1, 2, 3, 4 because these are not array elements. I am just printing out the numbers. So I will change it right now. Before, I am creating another string array, and string array is going to hold some string elements. Inheritance, polymorphism, abstraction, and encapsulation are going to be the elements of my array. These are the concepts of object-oriented programming at the same time. As you realize, instead of array, if I write down array2 in my argument, it is going to give me error. Even though my method is array printer, it's not printing out the string arrays, it's just printing out the integer arrays, and that's a problem. My point here is using the same method name, and I will be able to print out the integer arrays and string array at the same time. So instead of creating a different named method, I am going to keep the name, and I will change the parameter. Now I am creating the same named array printer, and this is going to have parameter of string array. Now I am creating another for loop, and I will write down system.println I. If I write down system.println I, of course I'm not going to be able to see these elements of array. What I need to do is I will change it into array square bracket I, so arr square bracket I. Now I can see the elements of the array, and I'll do the same thing for my integer printer. So now these two methods can print out the elements of the array. Now 1, 2, 3, 4, 5 is the elements of my array. So with using the same method name, I am going to put string array right now. Before it was giving me error, but right now when I use it, it will print out the elements, and I'm changing and I'm seeing the integer arrays. Well, if I comment one of these methods and try to put string array argument, then it is going to give me error. But if I uncomment this array printer string parametered array printer, it will accept my string arrays and it will be able to print it out. So this is important. What I did is I can right now use different parameters with the same method name, and the point is I can change the access modifier also, and even though I change the access modifiers, I can still use the same method name and it is still overloading. In overloading, the important thing is only method name and parameters need to be different. Other than that, I will be okay. Access modifiers can be different in method overloading. Also, return type can also be different in the method overloading. I can basically change my method type, like void type, into integer or double. Now I'm changing integer, and if I change into an integer, I need to have like a one return type, and I will put 0 here. This 0 doesn't represent anything, but in order to have integer type of method, I need to return something, so that's why I'm putting 0. But even if I use this method right now, it will print out my values. This 0 is useless right now here, and this is overloading in polymorphism. Thank you so much guys, and see you at another tutorial. Hi guys, this is Ahmetcan Türk. In this tutorial we are going to go over overriding in polymorphism. As you know, Polymorphism is consist of overriding and overloading, and in this example we are going to learn overriding. So let's get started. We have overriding concept class, and in this class we will demonstrate overriding concept in polymorphism. Overriding occurs when there is two class and these two class have inheritance relationship. Now we will create at least two class and they are going to have inheritance relationship. We will create methods and these methods are going to have the same name, the same parameter and the same return type, and in this case we can call it overriding. I'm going to create my class. It's going to be named as shape, and I believe in this example we will understand good that why we are doing overriding in our classes. Again, we are trying to reach the polymorphism. Well, I created one method area, and this area method is going to be different for my other classes, other subclasses. Well, all the shapes have area, we know that, but in order to calculate the area for the different kind of shapes, we are using different kind of formulas. So shape class has area method. In order to find the area, we need to use different formula for different shapes. That's why we need to override the area method in subclasses. And in order to override the methods, class needs to be in inheritance relationship. I'm going to write down everything here as a comment. Now I am creating my another classes. They are going to be rectangle, square and circle classes, and they all are going to inherit. They are all going to extend to my shape class. Now the next step is I am going to override this area method, and if I write down area and hit enter, my Eclipse is going to create this overrided area method by default, and I will see super.area statement right here. This super.area is basically calling the area method from the super class. I'll keep that in here, and I will change this area void area method with finding the area. I'm going to print it out. So whenever I call rectangle area, basically finding the area message is going to be pop up in my output. Now I will start to define the rectangle area method. I'll say in order to find the area, or let's make it something more proper, I'm going to say rectangle area is width times length. Next thing is I'm going to add two fields to this rectangle class. I will add integer width and integer length so that I can calculate my area in my area method. Now I am defining my area method again, and I will say the area is width times length. Now my rectangle class is ready. I'll create another class which is going to also extend to shape class. It's going to be named as square, and as a field it's going to have side, integer side, and I will define the area method in there also. I'll just write down area, or I'll copy this. I can do both of them. Okay, I write down this area. This is also overridden. Now I'm creating my integer side. This is a field, and I can define the area formula in my area method, and instead of width times length I will put side times side. I will do the same thing for square class. I copy the whole square and I will change it into circle, and the circle, instead of side, it will have radius, and in order to find the area I need to find the radius square times pi, and I will define it right now. Now I'm writing down I will use math class in order to reach out the pi value. So math.pi times math.power radius to the square. So math power method is a special method in order to find the power of the numbers. I will put 2 in order to find the square, and I will multiply it with the math.pi. This is another static field which is a close number to the real pi number. As everybody know, pi number is unreal number. So this math.pi is returning me the closest number to the pi. Now this is going to return me the circle area. Well, my classes are ready. I overrided the area method in different classes, different subclasses. Again, what is overriding? I am using the same return type and same method name, and I'm using the same method name in my subclasses. So let's create our object, rectangle, rectangle equals new rectangle, and I will do all of them. I will create rectangle, square and circle objects. Now I'm going to set my fields for each object. Rectangle has length and width, square has height, and circle has radius. I'll set the values one by one. If I call the rectangle area method, well, the shape method is running, and also area of the rectangle method is running. Actually, the reason that shape area is calling, because in my rectangle area method, I am calling this superclasses area method. So now I am finding the area, rectangle area equals width times length, and area is 30. I'll do the same thing for square and circle. Now I am updating this area methods a little bit. I will update the circle area method also because there's an extra space. Now they're good. Now I am calling all the area methods, and I can see different values in the console. And the point here is we are using different formula for different shapes areas. Well, we will do that a lot, guys. We will use overriding a lot, so better learn it good. We are basically creating this we are basically redefining this area method in the subclasses. Now I will modify the shape area method a little bit more. I'll add some stars to differentiate the different shapes, and now this is better. Okay guys, thank you so much, and see you at another tutorial. Hi guys, this is Ahmetcan Türk. In this tutorial we are going to learn abstract classes in Java. As you know, abstract classes are one of the part of abstraction concept in object-oriented programming. We are achieving abstraction with using abstract classes and interfaces. Let's see one example. I created abstract concept class. I am creating my first abstract class right here with using abstract keyword and class name and open and closing curly brackets. So this is my abstract class. Abstract classes are part of abstraction concept in object-oriented programming, and we can reach the abstraction with using abstract methods. There is one rule: in order to create abstract methods, our classes should be abstract class, and abstract methods actually represents the ideas, and the ideas will be abstract methods, and actual calculation will be implemented methods in the implementer classes. Now I am creating one method which is abstract float area. As you guys know, all the shapes, every shape has some areas, but in order to calculate the area, I need to have different formulas, and these different formulas are going to be implemented at implementer class. We will extend our square, circle and rectangle classes into the shape class, and they will have different formula to calculate the area of the shapes. We need to implement our abstract method in the implementer classes unless the implementer class itself is an abstract class. Now if you see, we have class square extend to shape, and now it is giving me underlined error. I need to implement my area method in my square class because it is abstract method, and I extend to shape class. And if you hover over and click the first link, you will have automatically one area method. This is overridden method from the abstract class. Now in order to calculate the area, my square need to have some attributes and fields. I'm going to say integer rectangle, and I'm going to say integer
And this integer width and length is going to be initialized in my object with using my constructor. So I will create a constructor, and this constructor is going to initialize my fields. I'll create two parameters, and this two parameter is going to initialize my fields. Now in my area method, I can use these fields in order to find the area. I'll basically create one area variable, and we will calculate the area inside, and then we will return this area variable. And even though my method is float type, I can return the integer because float is bigger than integer in term of size, so it's not going to give me any problem. Now the area method is ready and my class is all ready. We will create different kind of classes such as circle and rectangle, and these classes, guys, are going to use different formula in order to find the area. Now this is the circle and it's extend to shape. If it's extend, it need to have area method, otherwise my program is going to give me error. And now I have my implemented method. I will create my formula, but before I need to set my circle's fields. Circle has radius, and I need to use pi, number of pi, in order to calculate the area. So the pi is going to be static double because it's unchangeable, and I will assign it to a special method which is math.pi. It's specifically giving me a really close number to the pi, and we will calculate our area with using these fields. Instead of return 0, I'm going to use pi and radius, and I'm using pi times math.power. This is a special method, and it's helping me to find out the square of the radius. The right side represents the power number. You can change it. If you change it 3, you will take as cube. Right now I downcast my double value to float, and my method is ready. And the next thing, I'm going to create constructors for this radius. My constructor is also ready. I right click and generate constructor from the source. Now the circle is also ready. The next thing is square. I'll create a square class, and the square class is going to have only side, and it will extend to shape abstract class, and I will override, and there you go. Now the square class is going to use integer sides, and I will create one constructor for this. Now I can calculate my square. It will be basically side times side. If you want, you can use math power side to the 2. It is also possible. Now I'm checking everything. Oops, there's one more square class. It's supposed to be a rectangle class. I'm gonna change its name because rectangles have width and length. I'm gonna change it to rectangle. And if I change the class name to rectangle, I need to change also constructor name because constructor names always same with class names. Now it's good. All the classes are ready. Circle, square, and rectangle, and they have their own formula in order to calculate the area. Next thing is, I'm going to create object for each of the classes, and we will assign the side, radius, and width and length for each of the classes, and we will call their area methods. As you can see, we created the objects, and I will call the methods one by one. I call the object, and when we run this program, we will see every area of these specific classes. I basically overwrite my abstract method in the implementer class, and we have our different formula for area method. This is all about abstract concept, guys. Thank you so much, and see you at another tutorial.
Hi guys, this is Ahmet Can Türk. In this tutorial, we are going to learn what is encapsulation in Java and how do we implement encapsulation in Java. So let's get started. I have my encapsulation class. Encapsulation is basically hiding the data, and we will use private keyword to encapsulate our data. Private keyword will enable my fields and methods be able to reach out within my method, but these fields and method will not be able to be reach out from the outside of the class. So these fields and methods which have private access modifiers are going to be only reachable inside of my method. So it will hide my data from the outside of the class. I created my first string, private string name, and then private string ID number, and private integer age. We are using this encapsulation in order to hide our data, and while hiding our data, we are creating some ways to change these fields and manipulate these fields in some way. There are a couple of ways to change and manipulate this data, private data. Let me define everything. Private keyword will hide the data within the class. By the way, encapsulation is one of the four concepts of object-oriented programming. So this is very important. In order to reach the methods and fields, we will use additional methods. In this example, we are going to use getters and setters in order to change our fields. Well, I can basically create my getters and setters with right click and source and generate getters and setters. I'll click on that and I will choose fields from this option. Let me click on this. I will choose all the fields and Eclipse is going to generate automatic getters and setters for me when I click on that. And right now I have a bunch of methods ready to use. Now the next thing is I am going to create run encapsulation class, and we have main method inside. From this main method I will create one object for my encapsulation class, and I'll create another object for my encapsulation class, and I am creating both of them in one statement. Now is the time to manipulate these fields. I'll use my object to reach out these setters, and setters are going to help me to print out the values, setters are going to help me to manipulate the values. Now I assigned all the values to my fields. I'll do the same thing for object 2. Setters are so important method, guys, and these setters are help me to reach out this private data. Without these setter methods, I cannot reach out directly to these fields. There is another way actually to reach out. Another way to initialize the fields is constructor, but right now we are changing our field with setters. Next step is I will create one info method in the encapsulation class, and this info method is going to print out all the fields and values in my encapsulation class, of course depending on the different object. I'm creating my info method, and this info method will print out all the fields in this class. But as you realize, these fields are variables, and in the run encapsulation class I am setting these fields, and every object has different values for the fields. We have name, ID, age fields, and these fields are different for every object. For example, object 1 name is Ahmet, but object 2 name is Mike. Object 1 number is 4298, but object 2 ID is different. Now I created my info method, and this info method is going to print out all the fields, and depending on the object type, depending on the object, these info methods, get name, get ID number, and get age methods are going to return different values. When I call object1.info and object2.info, of course in the middle I'll put like some stars to differentiate the values. Now I can run my program. Well, this get name of course is going to be different for object 1, and different for object 2. So it will be different for different kind of objects. When I run this program, I will see name Ahmed for one object and Mike for other object, and ID and age also changing. Okay, thank you so much guys. This is all today. We covered everything about encapsulation and hope to see you guys in another tutorial. Hi everyone, this is Ahmet Çantürk. In this tutorial, we are going to learn interfaces in Java. Interfaces are basically one of the sub-concepts of abstraction in object-oriented programming. As you know, we are reaching the abstraction with using interfaces and abstract classes in Java. And today we are going to go over the examples of interfaces. So let's get started. I created my first interface concept class, and we are going to create interface in this example. Interfaces are one of the abstraction concepts. We can reach to abstraction with interfaces, or we can reach multi-inheritance with interfaces also. Let's create our first interface. We are going to use interface keywords and we will name it with as I interface and open and close curly brackets. This is going to be my interface, and inside of the interface we can create some abstract methods. I will make a void type of method. So the methods in the interfaces doesn't have body necessarily. We can create non-bodiless methods without bodies. So this is abstract method. Abstract method means methods which doesn't have any body. Well, the body of the method is going to be inside of the implementer class that I am creating right now. Class B implements I interface. When we are implementing our class to our interface, it will give us some error, underlined error. This means we need to implement these abstract methods in the interface. We have void message abstract method in our interface, and we need to implement it in our implementer class. In this case, my implementer class is class B, and we will overwrite the void message in our class B class. When we hover over to this underline and click on the first link, Eclipse is going to create me automatically overridden method. If it doesn't show up on you, just you can write down manually. Now this is overridden method which is coming from I interface. We can implement our method right now and say this is message from class B. I will also change my class name into class B with the uppercase. Now we have our interface and implementer class. Just keep in mind, interfaces cannot be instantiated, which means I cannot directly create an object for my interface right here. In order to reach the method, I am going to create an object for the class B. Now in my main method, I am going to write down that interfaces cannot be instantiated, and I'm going to create an object for my class B. After creating the object for class B, I am going to call the message method with my class B object. If we run this program, as you can see in the console, we are going to see message from class B. This message from class B is coming from with this object. I copy and paste this message next to my statement. Now instead of in my statement, instead of class B equals class B, I can use my interface name in the left side of the equation, and we are calling it as upcasting. You can find in the tutorials what is upcasting. We have also another tutorial for that. And now if I use my upcasted object and call the message again, well, same message is going to come from the output. In this case, my upcasted object doesn't act differently from my regular object. If you watch the video about upcasting, you can see what is the difference between upcasted object and regular objects. Now I'm creating another class for another example. and I will name this class as interface concept 1. I will drag it to the top and we will start to write down our code. First of all, I will create one interface which is going to be named as iMovable. I changed my class name into interface concept 1. Now let's create our interface. We need to use interface keywords and interface name. As you realize, I am writing down my interface name with the capital I and the interface name. All the classes which implements to this interface will have movable attributes, which means every class which is extending to my interface will be able to move, in other words. So all of them is going to be movable. As you realize, guys, we have some kind of contract between interfaces and classes. Well, all the methods in our interface, all the abstract methods in the interfaces needs to be implemented in our implementer classes. This is so important. This is a rule, and I will know that if one class implements to my iMovable class, then it will have movable attributes. Now I created my integer average speed, which is 60. All the fields in my interfaces are final by default. We don't need to use final keywords. All the fields are final by default. So no final keyword needed. And I will create my another method, which is going to be abstract method. I will name it as move, void move, and it will have no body, which is, it will be abstract method. If we have an abstract method in our interface, that means every class which is implementing to this interface will have this implemented method of move. Now I am creating my another class which is going to be named as vehicle, and it will implement to my iMovable interface. Now I will have underlined warning, and if I hover over it and click on the first link, Eclipse is going to generate automatic implemented method for me, and this is going to be same name as the implemented interface abstract methods. Now I will write down system.println and average speed is plus average speed. Well, this average speed that I'm writing down here comes from interface on the top. As you can see, I have access to interfaces fields from the implementer class. Now it's time to create object for my vehicle class. I created my vehicle object and I will call this move method, and in the console I will see average speed is whatever I put it, and it is 60, and this average speed is coming from interface. When I run this program, I will see average speed is 60. I can use upcasting again. I can write down my interface name in the left side, and I can give a reference name which is like vehicle 2, and in the right side I will have implementer class's name which is vehicle. I call the method with using this reference, and we will see the same output. As you realized, objects are acting same. In this example, creating object with upcasting or normal is not different. I will create another class which is interface concept 2, and in this example we are going to go over multi-level inheritance on interfaces, and we will basically connect two interfaces to each other, and we will see how implementer classes are acting. While I'm writing down this definition, let me tell you something. If we connect two interfaces to each other, my implementer class is going to implement all the abstract objects in these two interfaces. I created my first interface which is iVehicle, and I'll create another one as iCar, and I will create another one as iMotorcycle, and these iCar
it is going to be extend to I interface, I vehicle, and then my I motorcycle is going to extend to I vehicle at the same time. As you realize, guys, if I connect two interfaces to each other, I am using the extends keyword, but if we are connecting the class with interface, we are using implement keyword. Now I will start to create methods for my interfaces. I'll create different kind of methods. I created 2 methods for iVehicle. I am creating 3 methods for iCar, and I will create another 2 methods for iMotorcycle. As you realized, vehicle interface has methods which any vehicle can have, and iCar interface has methods which any car can have, and iMotorcycle interface has methods which any motorcycle is going to have. I will write down that any class which is going to implement these interfaces, iCar and iMotorcycle, they will need to implement the methods, their methods plus their super interface method. So any class that is going to be implemented to iCar is going to implement 5 methods, and for motorcycle it is 4 methods. 2 from iVehicle, 3 and 2 from iCar and iMotorcycle. Let's create one class, and this one class is going to implement to iMotorcycle, and let's see how many implemented method I need. I am writing down a class Kawasaki, it's a brand, implements to motorcycle, iMotorcycle, and I will overwrite all the methods that need it. When you hover over to this Kawasaki and click on the first link, all the methods are going to come automatically, and as you can see, 1, 2, 3, 4. We have 4 implemented methods. Top 2 coming from the iVehicle, and bottom 2 is coming from iMotorcycle. This is how the multi-level inheritance works in our interfaces. If we are creating an object for Kawasaki class, then we will be able to have access to these 4 methods which I implemented. Well, same is going to be for another classes. Now let's create another class which is going to be named as interface concept 3. In this example, again we will see 2 interfaces extend to each other, and we will have one class to implement one of these 2 interfaces. Let's create our interfaces. They are going to be named as interface 1 and interface 2, and interface 2 is going to extend to interface 1. Now we will add one method to each interface. They will be named as F1, and the other one in the interface 2 is going to be named as F2. Next step is we will extend our interface concept 3 class we will implement it into interface 2. And as you can guess, we need to implement our unimplemented abstract method from interface 1 and interface 2. And if we do that, if we click on that, we will see public void F1 and public void F2. And I'll create another method which is public void F3. And all the methods are going to have message inside, such as this is content from interface concept 3, this is content from interface 2, and this is content from interface 1. My methods are ready, and if we are creating an object for interface concept 3 and call each of the methods, we will see the messages inside. This is our output, and I will print out, I will copy that right next to each statement. Now I'll run it again, and as you can see, these are messages. And I will create one more example. This is going to be the last example. I'll name the class as interface concept 4. And in this example, we will see static and default methods. And these static and default methods are going to have body in the class. So far we saw interfaces which have methods and the method has no body, but right now with default and static methods we will be able to create method which has bodies. I am creating my first interface, iInterface2. I'll name it as iInterface2 because I already created iInterface in other classes. So in the same package I cannot have two same interface name. And I'm going to create static method in right here, static void method 1, and it will print out static method in interface. If we implement our class into this interface 2, as you realize, I have no error because I don't need to implement this method 1 in my implementer class because this method already have body. So we don't need to implement static methods in implementer classes. Another method that have body is default method in the interfaces. We can create default method 2, and this method also has body. And even for this method, I don't need to implement it in the implementer class because this method 2 also has body. So any method that has body doesn't need to be implemented in implementer classes. Now I will create object for interface 2 and we will call this method, and I will call this object 2, and we will see that it is going to print out this default method in interface. If we try to call the method 1 with the object, it will give us compiler error. When we run this program, we will see these messages. So thank you so much guys. This is all about interfaces and hope to see you at another tutorial.